Hello all. Today I'm going to explain on the DNS. So how the Google finds the servers. So why the DNS exists? DNS hierarchy, root and TLD servers, NS lookup and dig, real examples. So why the DNS exists? So basically if you're calling a friend, so you don't call just by their home address, you just dial their phone numbers, but you remember their names, not their number. The computer talks with IP addresses. Nobody wants to type that. We want to type like google.com instead. So DNS translates the human-friendly domain names into the machine-friendly IP addresses. It is automatic and instant. So this is the flow. You type the google.com, the DNS will get this IP addresses and it will get connected. And you don't need to memorize the billions of IPs address. Next is the domain names and DNS hierarchy. Invisible root always will be there, and top level domain is .com, registered name is Google, optional prefix is www. And this is the hierarchy, lookup hierarchy, root DNS, and it has the 32 root clusters globally, and this will go to the TLD server and TLD server, authoritative, and this is also authoritative. So this is .com, .org, .net, .one, and this is .uk, .one, .jp. Root servers and TLD servers. Root servers is 13 named root servers A through M, actually 1500 plus physical servers worldwide, run by ICANN, NASA, Origin, and others. We know where to find the TLD. First is stop in every DNS query. TLD servers, .com managed by version, .org managed by public interest registry, .in managed by NIXI India, one managed by .com registry. They point to the authoritative DNS. So authoritative DNS server holds the actual record of the specific domain. When you host a website, your hosting provider runs an authoritative DNS. So like IPv4 address, AAA, CNAME alias, makes mail servers, and TXT text records. See, this is the resolution flow, like how your browser finds the euron.one example. Your browser type euron.one, it goes to the resolver, it checks with the ISPs, then it will go to the root servers, knows one TLD, and then this goes to the TLD server, points to the NS authoritative, it returns the IP address, and browser it connects and the page loads. So step 1 and 2, it will cache the check. So check if it's cached, if found in millisecond, if not continues to root. Step 3, it will, I don't know the euron, but one TLD is at, this is the IP. TLD server, it will go to the TLD server, it returns euron.one users, name servers example, and then at 5th returns the actual record. This is how the resolution flow, how the browser finds the euron.com. So this is the practical NS lookup and dig. NS lookup, so NS lookup google.com, this is the server. If you type just in the command prompt in google.com, this is the server and this is the address. And if you query the specific type, like example NS lookup hash type is equal to mx google.com, use the specific DNS server, nslookup lookup euron.one. So if you dig euron.com, answer is this one, short output only, dig euron plus short, trace full resolution plus trace. So query mx records, dig mx euron.com plus short. How the browser finds the euron.one. Example, if you type the http euron.one, the browser cache first checks its own memory previously visited, done in less than 1 milliseconds. And the next is OS cache and host cache. Check etc host and OS level DNS cache, usually missed to recursive resolver. Asks your ISP resolver, checks if the cache for euron.one. Root server asks root who handles one, returns .one TLD server IP. TLD server asks .one registry who is authoritative for euron.one, returns the NS records. Authoritative NS returns record euron.one. So the entire process is about 20 to 120 milliseconds, and DNS TLS cache results for a minute to hours. Thank you.